Okay, this is the Math 2 Unit 4 review for Mrs. Vergadamo's class. Number 1 says DE is a midsegment of triangle ABC. Find the value of x. Any midsegment is half the value of the side that is parallel to it. So I'm not going to set these equal to each other, but instead, if this is half the size, I want to double it and set it equal to the longer side. So I'm going to say 2 times x plus 5 equals 3x minus 1. Make sure your x plus 5 is in parentheses. We're going to distribute that. So I get 2x plus 10 equals 3x minus 1. I want to move all of my x's to the same side. So I'm going to subtract the smaller one to the right-hand side. That would give me 10 left on the left. 3x minus 2x is going to be 1x, or just x. Then I want to add the 1 to the other side, so 11 is going to be equal to x. Now it says find the value of x, so I just need to box in my answer because x is equal to 11. If it asks me to find DE, I would want to plug that back in. If it wants me to find CB, I would want to plug that back in there, but it just says find the value of x. For number 2, DE is a midsegment of ABC, and AD is 15, AE is 14, find AB. So I want to write those in, 15 over here, 14 down here. Now, these are similar triangles, which we will learn more about later. We talked about how if this triangle, this smaller triangle, is blown up twice the size, then this length would be equal to CB down here. My midsegment would be equal to my base of CB down here. Now, that means each of these are going to be blown up to twice the size, so this would be 14 as well. If it asks me for AB, that would be this entire length, AB of 28. So you're going to write AB is equal to 28. For number 3, which list could be the measures of the lengths of the 3 sides of a given triangle? If it makes a triangle, then your 2 smaller sides added together must be larger than your third side. So we're going to do 5 plus 8 and see if that's greater than 15. 5 plus 8 is 13. Is 13 greater than 15? No. The next one, 2 smaller sides are 10 and 12. 10 plus 12 is 22. Is that greater than 20? Yes. And then I would always make sure to do all of them. In some cases, they'll say select all that apply. In other cases, you want to make sure you're picking the one that is different, just to check your work. So if I check these, if I do 10 plus 15 greater than 25, that gives me 25 greater than 25. Is 25 greater than 25? No, because it doesn't say greater than or equal to. And the last one, 18 plus 2. 20 is not greater than 15, so that's also no. Your answer is B. Number 4, list the order of shortest to longest side in triangle ABC. Within a triangle, your shortest side is going to be opposite your smallest angle. So my smallest angle here is 40. If angle C is my smallest angle, then C will not be included in the shortest side. Across that is AB. AB is my shortest side length. So if it's talking about list the order of sides, then you want to do it as a segment. If it says the lengths, you can leave out the segment above. The next angle, the next largest, is 55 degrees, which is angle A. So A won't be included in that. So BC is across from A. So BC is my next longest segment. And my largest segment is across from this 85 degrees, which would be AC. Number 5, the lengths of two sides of a triangle are 41 and 23. What are the possible lengths of the third side? What the triangle inequality theorem has shown us is if I try all the possibilities, there's all these different, I can do it like above, and I can say 41 and 23 are both the smallest, and I can do all those possibilities. Or I can say 41 is the largest and 23 on the other side are the two smallest. But we figured out that if I just subtract these, that gives me my bottom end of my possibilities. So 41 minus 23 gives me 18. And then 41 plus 23 will give me my larger side, which would be 64. So x has to be somewhere in between there. Cannot be 18, cannot be 64, but anything in between works. Number 6. Match the line with the correct description. So for a perpendicular bisector, we need to know what a perpendicular bisector does. A lot of these have perpendicular qualities, but a perpendicular bisector must be perpendicular, meaning 90 degrees, and a bisector means it cuts something in half. So if I cut something in half from a midpoint to the opposite vertex, a midpoint does cut something in half, but a perpendicular bisector does not have to go through the vertex. Bisects an angle. A bisector here, if we're talking about a perpendicular bisector, we're talking about cutting a side length in half. Perpendicular to a side and goes through the opposite vertex. We don't have anything about cutting something in half or a midpoint, so that's not it. A perpendicular line through the midpoint of a side, that would be a perpendicular bisector. An angle bisector would bisect an angle, that's pretty obvious. A median is going to cut a side in half, but it's going to go to the vertex. Both of these last two go through the vertex. So if it's a midpoint to the vertex, that's a median. If it's perpendicular to the vertex, if it's perpendicular and goes to the vertex, then that is an altitude. Number 7, match the point of concurrency with the lines. So all of my centers here, if I have perpendicular bisectors, 3 perpendicular bisectors make a circumcenter. 3 angle bisectors make an end center. 3 medians make a centroid. And 3 altitudes make an orthocenter. So if you know how the ones work above, you can see which ones to match to the centers, because if you know what an altitude is, then you just see the one that has 3 of those, and that will give you an orthocenter. Which segment would be the shortest? Number 8. Which segment would be the shortest? So the way you want to compare these without making an error is to check each triangle. In triangle WXZ, the shortest side is opposite the smallest angle. So in that triangle, opposite of 50 is XZ. In the next triangle, XYZ, the shortest side is opposite this 42, because 42 is less than 45, so ZY. Now, after you determine those two, then you can compare between the two triangles. XZ and ZY is in, both of those sides are in one of the triangles. So if I cover up the left-hand triangle, both of those sides are in the right-hand triangle. We already determined that in that right-hand triangle, ZY was the shortest side. So that trumps the first triangle. and your overall answer will be ZY. Moving to the next page, number 9. It says find AD. AD is one of your segments right here. We have this angle C, BCD, angle C here, has been cut into half and cut in half. So these two are congruent, and these two angles are congruent. So we do have an angle bisector, which means these two sides are also congruent. So if those sides are congruent, I can set them equal to each other and solve. I'm going to subtract 3 to the other side. 2x minus 3 is going to equal 1. Add 3 to that side. 2x is equal to 4. And that means x equals 2. Now this says find AD. So make sure you know what you're solving for. AD is this bottom left-hand side. So I'm going to plug in 3 times whatever my x value is, which is 2 plus 1. 6 plus 1 is 7, so AD equals 7. Number 10, find the measure of DEF. DEF is this entire angle at the top, which is composed of two angles that are actually congruent to each other, because if I have two sets of congruent sides, then that angle is also congruent because of my angle bisector. So I'm going to set these two sides equal to two angles equal to each other. 3y plus 4 equals 5y minus 10. Start solving. Add 10 to the other side. Y is equal to 7. Now, it does not matter which one I plug back my y into, because I'm going to actually need both of these in order to find this entire angle. So if I plug it into this left-hand side, 3 times 7 plus 4, that gives me 21 plus 4, which is 25. These two, I set them equal to each other in order to solve, so that means they are congruent. That's why I set them equal. So I can just double that 25 to get the measure of angle DEF. So 2 times 25, which gives me 50 degrees. Number 11, x is the midpoint of MN, y is the midpoint of ON. First we want to find XZ. XZ is here. That means XZ is parallel to NO, which makes it the mid-segment, or one of my mid-segments, but the mid-segment that's parallel to NO. So XZ has to be half of NO. So XZ equals 9. XY equals 10, so find MO, we just need to double it. That's 20 because that's my longer side. And then it says if angle M is 64 degrees, find the measure of angle XYZ. So XYZ, this angle here. What we haven't really talked about too much is quadrilaterals. We're going to go over that more in the next unit. So these sides are parallel, we talked about, because they're mid-segments. This is also parallel to this, so we know that opposite sides in quadrilaterals are congruent, so the measure of angle XYZ is equal to 64 degrees. Number 12. Find the measure of AB. They are, AB is marked congruent to BC, so I'm going to set those equal to each other. Subtract 2x to the other side, x minus 2 equals 4, add 2, and I get x equals 6. If I plug that 6 back in for AB, AB equals 3 times 6 minus 2, which is 18 minus 2, which is 16. That equals 16. AB equals 16. For the next one, we have find the value of x. And again, I have two congruent side lengths. So I'm just going to set those equal to each other. That should be a 7x plus 3 if you can't read that well, because it's a little faded. Set that equal to 10x minus 9. Subtract 7x from each side. I get 3x minus 9. Add 9 to each side. And divide by 3. I get x equals 4. Number 14. Which is the smallest angle in triangle MNO? The smallest angle is going to be opposite the smallest side. So first of all, I find the smallest side. Oops, sorry. Smallest side is 17 yards, which is NO. The only letter that's not an NO is M, so angle M is my smallest angle. Number 15, order the sides from shortest to longest. Opposite of my smallest angle, 59, would be DE, so that's my shortest side. Then opposite of 60 would be DF, and my largest side would be opposite of 61, which is EF. On to the back side, number 16. Two sides of a triangle are 5 and 10 inches long. What is the range of possible lengths for the third side? We've talked about this. We add those together to get our largest possible number. So 5 plus 10 is 15. 10 minus 5 gives me my shortest side, which is 5, and x must be between those, so 5 is less than x, and x is less than 15. That is your range for your third side. Number 17, the coordinates of the vertices of a triangle are, A is -2, +3. I want to fill all these in as I go. B is 0, -5. C is -4, -1. So those are my three sides of my triangle. You want to make sure that you are drawing in a straight line. Use a straight edge. Ruler, ID card, whatever straight edge you can find. Alright, then I want to find the coordinates of D, my midpoint of AC. So, sorry, I need to go back and label these, B and C. So the coordinates of D, my midpoint of AC, I can find the midpoint formula, which is the average of -2, 3, and -4, -1. The average, if I add up my x values, I get -6, and divide by 2, I get -3, so 1, 2, 3. If I go up, you can already see where that overlaps. You just want to check your values here. 3 and -1. If I add 3 plus -1, I get +2. 2 divided by 2 is 1. So all I did was take the average of my x and the average of my y. But you don't have to do it that way, and that's why I didn't write it down, is because you can actually do it through the slope as well. If I'm going from C to A, I'm going up 1, 2, 3, 4 over 2. up 4 over 2. Halfway along that path will be up half as much and over half as much. So instead of up 4, I'm going to go up 2. Instead of over 2, I'm going to go over 1. And you get to the same point. So as long as you find the coordinate of that point, you're good. We're going to label that D. So that's negative 3, 1. For E, I'm going to use that slope again instead of taking my averages because it's pretty easy to find as long as your numbers line up. So from CB, I'm going to go down 1, 2, 3, 4 over 1, 2, 3, 4. So both of them are 4. I cut both of those in half. I get 2 and 2. So I'm going to go down 2 over 2. Here's my new point. For my midpoint of CB, it's negative 2, negative 3. For F, if I go from A to B, I'm going, let's go from B to A so I can do my rise over run and see. 1, 2, 3, 4, 5, 6, 7, 8, and back 2. So instead of going up 8, I'm going to go up 4, which is half as much. 1, 2, 3, 4, and over 1. Those are my 3 centers. You want to make sure to label them. My point for F is negative 1, negative 1. And then I'll go ahead and draw those in. Oops. Okay, so I drew them in different colors. I'm going to zoom in so you can see that. DE is in orange, DF is in blue, and EF is in pink. A little hard to see, but I'm going to calculate each of their slopes and their distances using those respective colors so that you know which one I'm talking about. So, first of all, I need to calculate the slope, or use the slope, in order to show that the segments are parallel. And you need to do this with each mid-segment. So, if I'm talking about DE first, DE, I want to show it's parallel, the segment DE is parallel to another segment. DE and AB are going in the same direction, so those are the 2 I need to calculate the slope for. Slope of DE equals, I can use a slope formula, which is going to be m equals y2 minus y1 over x2 minus x1. Or you can just count your rise over run. Make sure you have the correct positives and negatives for the rise over run, otherwise you will get the answer incorrect. So for DE, my rise, I'm going down, starting at D, going to E, down 1, 2, 3, 4 over 1. Down means negative 4 over 1. For AB, I'm going to do my rise over run again. So starting at A, I go down 1, 2, 3, 4, 5, 6, 7, 8 over 2. Down 8 over 2, which reduces to negative 4 over 1. Since those match, they are parallel. So I have checked that DE is parallel to AB. Now I need to check, is EF parallel to AC? The slope of EF, I'm going to go up 2 over 1. The slope of AC, I'm going to go up 1, 2, 3, 4 over 2. Make sure you reduce. 4 over 2 equals 2 over 1. They match, so that is in fact parallel right there. The last one, I want to check that DF is parallel to CB. So DF, slope, for rise over run, I'm going, rise means go either up or down. If I'm going to F, I'm going down 1, 2 over 2, down 2 over 2, which reduces to negative 1 over 1. CB, I'm going down 1, 2, 3, 4 over 1, 2, 3, 4, negative 4 over 4, which also reduces to negative 1 over 1. So those match, a little tight there, but they are parallel because they have the same slope. Okay, now number 17, letter C. If we're trying to find the lengths and make sure that the lengths of each mid-segment is half of the parallel side, we want to use the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. So, if you're checking DE and AB, you want to make sure you have each of your points for DE. So DE, my point for D is negative 3, 1. My point for E is negative 2, negative 3. Okay, so when I do DE, I'm going to subtract my x values, so negative 2 minus negative 3. If I subtract a negative 3, that's the same as adding 3. And then I do negative 3 for my y values minus 1. So negative 2 plus 3 gives me 1 squared. And then I get negative 4 squared. So that gives me the square root of, let's see, negative 4 squared is 16 plus 1 squared, which is 1. 16 plus 1 is 17. So I should get the square root of 17. Then for AB, my A value is negative 2, 3. My B value is 0, negative 5. So to find that distance, I'm going to be doing subtracting my x value, 0 minus negative 2. Subtracting a negative is the same as adding a positive. Then I subtract my y values, negative 5 minus positive 3, so minus 3. That gives me 2 squared plus negative 8 squared, which is 4 plus 64, which is 68. Now, right now I can't tell if 68 is double 17. So what you could do is change those to the decimal values. So if I plug these into my calculator or my phone, I'm going to do 17 and take the square root of that. I get 4.12 approximately, 4.12. And do the same with 68, 68, and the square root of that is approximately 8.24 or 25 if we round up, but if 246, but you can see that we're doing approximations, so it's going to be pretty close. And 8.24 would be double 4.12, so you're going to tell me DE is equal to half of AB because 4.12 is half of 8.24. And that shows that the two distances, the mid-segment is half of the outer segment. Now you're going to do the same thing for the next two. I'm just going to go through them quickly because you should get the idea from the first example. Point for E is -2, -3. F is -1, -1. Don't forget, if you're subtracting a negative, it's the same as adding a positive. This gives me 1 squared, square root of 1 squared plus 2 squared, which gives me the square root of 5. I'm going to do the same for AC. A is -2, 3. C is -4, -1. Subtract your x's, subtract your y's, that gives me -2 squared, which is 4, -4 squared, which is 16, 16 and 20, so the square root of 20, the square root of 5, try to get this out. There we go. Square root of 5 is 2.23. The square root of 20 is 4.47. 236. So you're going to tell me EF is half of AC because 2.236 is approximately, it's not exactly, because I'm rounding, 47. Oh, sorry, 47. If it was 2.35, it would be exactly 4.47, so it's very close. And then the last one, point D is -3.1. Point F, -1, -1. Gives me 2 squared plus -2 squared, which is interesting. 2 squared is 4. -2 squared is 4. 4 plus 4, 8. I'm going to do CB as well. C is -4, -1. B is 0, -5. -4 squared is 16. -4 squared again, also 16. That gives me the square root of 32. Now for all of these problems, you can do the decimal answer, but you can also just reduce each of your radicals. So if I do a factor tree on 32, factors to 4 times 8, this is 2 times 2, and this is 2 times 2 times 2. Now, I can take out in pairs of 2, so this would be 2 root 8, or I can take out in, there could be 2 2's that I take out, and that'd be 4 root 2. All of these are equivalent to the square root of 32. The one that's important to see is double the square root of 8. If I have double the square root of 8, I already know that that's double. Otherwise, you could also reduce this one, which would be 2 root 2. And if I double 2 root 2, I would get 4 root 2, which is also double my mid-segment. So no matter what, you can write DF is equal to 1/2 of CB, because the 2 root 2 is equal to 1/2 of 4 root 2, because if I divide that 4 by 2, I get 2 root 2. This is the radical forms, which you can see is much more precise than decimal form, because I have to approximate using decimal form, but either way is the correct answer. And that's it for the Unit 4 review.